Thank you and welcome to Professor Mi Zhifu or Zhifu Mi's professorial lecture. As many of you know, he was made a professor, a chair in climate change economics in July of 2022 with effect from October of 2022. Zhifu, as many of you may be able to guess, but it's certainly true, is one of the youngest professors at UCL. I think he is actually the youngest professor at UCL. He's had an absolutely extraordinary career at UCL. We were just reflecting before this conversation started that 6 years ago, he came to give a talk at UCL when he was a senior research associate at the University of East Anglia, and then applied for a research fellowship at UCL, was promoted very quickly to senior research fellow, then obtained through an open competition a lectureship, was promoted a couple of years later to associate professor, and then now has been promoted to full professor to a professorial chair. He is one of the most significant and influential researchers in climate change economics working in the UK, and is an absolute rising star globally. He's won a number of very significant awards, including the World Sustainability Award, and also the Forbes 30 Under 30. We're really honored to have Zhifu here as part of our team at BSSC. I actually regard having recruited him to BSSC to be one of my real achievements as head of department, because this has allowed us to build an unparalleled climate change economics and sustainability team that has in turn helped catapult BSSC from the least research intensive to the most research intensive unit in the Bartlett. And it's very fitting as a result that Zhifu is the director of research and is shaping our research strategy going forward. His research in climate change economics is an outgrowth of his career trajectory, which began at Shandong University when he majored in mathematics and operations research. He then did a PhD in economics, energy economics, and climate change economics at the Beijing Institute of Technology, and then the postdoc at the University of East Anglia, and then subsequently at UCL followed in short order. We know that Zhifu is an expert on climate change economics in the Nordhausian sense, but also in climate change economics more broadly. And I'm really excited today and very proud to be able to present to you Zhifu and his research plans as he settles into the professorial chair. So without any further ado, Zhifu, please.
Thank you very much, Dimas. Thank you for chairing this keynote lecture, and thank you very much for your kind words. Hi, everyone. Thank you for coming. This is Professor Zhifu Mi. I have been working at BSSC for 7 years. It's my great honor to deliver this keynote lecture. So today I'm talking about the research about international trade and carbon emissions. I have slides. I'm going to share my screen. So here is the background. International trade plays a critical role in the global economy by enabling countries to specialize in producing goods and services which they have a comparative advantage. So this is a good thing. So this can improve the consumption level and the economy all over the world. So today we're going to talk about its connections with carbon emissions. International trade and carbon emissions are closely interconnected. First of all, the international trade can be a direct driver of carbon emissions, as the transportation of goods often involves the burning of fossil fuels, so which release carbon dioxide into the atmosphere. In addition, the international trade can shift carbon emissions among countries. So over 20% of global carbon emissions are caused by the production of goods or services ultimately consumed in another country. So understanding the impacts of the international trade on carbon emissions is of great importance, as the world is trying to achieve net zero to limit global temperature rise to 1.5 degrees Celsius. So this is what we are going to talk about. So in our research, we estimate the carbon emissions embodied in trade. So what is the emissions embodied in trade? So embodied carbon refers to the carbon emissions that are released during the production of a particular product or service. These emissions are considered embodied in the product or service because they are a result of the inputs and processes used to produce it. So for example, we use phone, we use laptop. So in fact, all these products will induce carbon emissions. So we can see these carbon emissions caused by the production and transportation of this product as embodied carbon emissions. Due to the emissions embodied in trade, there are two different carbon accounting measures. The first one is production-based emissions, sometimes also called territorial emissions. These production-based emissions are emissions caused by domestic production together with exports, accounts for emissions at the point of production. It excludes the consideration of final use estimation or ultimately used consumers of goods. By comparison, the second measure is consumption-based accounting. Consumption-based emissions sometimes are also called carbon footprints. So under this carbon accounting measures, all emissions occurring in production and distribution sectors are allocated to the final product consumers. So there is a simple relationship between the two accounting measures. The consumption-based emissions equal to production-based emission plus emission embodied in import and minus emissions embodied in export. So here is a case. So when we talk about the production-based and the consumption-based accounting, so we need to understand the consumers and the producers of our products or service. So the left circle is consumption-based emissions. So it includes all emissions induced by the consumption within the country. And the yellow circle is the production-based emissions. So it includes all the emissions emitted in their production. So we can see there are overlaps between production-based and consumption-based emissions. So this the overlapped region indicates the emissions which are from the products which are produced within the country and consumed within the country as well. So these are the relationships between the production-based and consumption-based accountings. So generally speaking, developed countries have higher consumption-based emissions, and developing countries have relative higher production-based emissions. Let's look at this case of iPhone. So I know many people use iPhone now. So this is iPhone XS with 64 GB memory. So to produce this iPhone, we need to emit 70 kg CO2. So if we assume that this iPhone is produced in China and finally consumed in the UK, so this is the trade, international trade. The products in this trade is iPhone XS. So we can see that 70 kg CO2 are embodied in this iPhone. So with the trade of iPhone, the carbon emissions are also traded virtually. So according to the production-based accounting, this 70 kg CO2 belongs to China because China is the producer and China emits these carbon emissions. From consumption-based accounting, this 70 kg CO2 belongs to the UK because the value of this iPhone is enjoyed by a UK consumer. So this is the differences between the production-based and consumption-based emission. So we can see that the differences are caused by the trade, are caused by the emissions embodied in trade. So if we have two countries, so here is another example to introduce the production-based and consumption-based accountings. If we have India and the USA, the India produced 20 MT food, so it emits 4 MT CO2. And India also produced 100 computers emitting 4 MT CO2. So USA produced 50 cars emitting 5 MT CO2, and also produced 20 MT food emitting 2 MT CO2. So we can say the USA emit less CO2 to producing the same amount of food. So maybe the USA has more advanced technology in the food sector. So what is the production-based emission for the two countries? So it's very easy to get it. So the India production-based emissions is 4 plus 4 is 8 MT, and for the USA is 5 plus 2 is 7 MT. So this is the production-based emissions. If we assume there are international trade between India and the USA, so India exports 100 computers to the USA. So emissions embodied in India's exports, i.e. the 100 computers will be the 4 MT CO2. And at the same time, the 4 MT CO2 is also the emissions embodied in USA's imports. So, and the USA exports 20 cars to India. So emission embodied in the USA's export, the 20 cars is 2 MT, because USA need to emit 5 MT to produce 50 cars. At the same time, this 2 MT CO2 is also emissions embodied in India imports. So according to the equation I introduced before, the consumption-based emissions equal to production-based emissions plus imports emissions and minus export emissions. So we can get the consumption-based emissions for the two countries. So consumption-based emissions of India is 6 MT, and consumption-based emissions of the USA is 9 MT. So this is a case to introduce the two accounting measures. So from production-based perspective, India has higher emissions, but from consumption-based emissions, USA has high emissions. So it makes sense. So generally speaking, developed countries have relative higher consumption-based emissions. So the both accounting measures, production-based and consumption-based, have advantages and disadvantages. There are many differences between the two accounting measures. So production-based accounting covers the emissions from the administered territorial, and consumption-based accounting covers emissions globally. And production-based accounting allocates emissions according to domestic production, and consumption-based accounting allocates emissions according to domestic consumption. As for the import and export, the production-based accounting includes export, not imports, but consumption-based emissions includes imports and not export. So there are also many other differences between the two accounting measures. So we are not going to introduce the details. So here is the production-based and consumption-based accounting for several countries or regions. So we can see USA and EU are net imports of embodied emissions, while China and India are net exports. So we can see that USA and EU have higher consumption-based emissions compared to their production-based emissions. So India and China, by comparisons, have higher production-based emissions. So, you know, in the international trade, the trade between North and South, North means developed countries, South means developing countries. So the trade between the North and South are very important part in the international trade. So generally speaking, the developing countries have relative higher production-based emissions because, you know, the gap between production-based emissions and consumption-based emissions are caused by the emissions embodied in imports and exports. So the emissions embodied in imports and exports can equal to the imports or export value times emission intensity. Emission intensity means carbon emission emitted to produce 1 unit of products. So developing countries usually have a relative higher carbon emission intensity. So this is why for developing countries, the emissions embodied in their exports are usually higher than emissions embodied in their imports. So if we compare the carbon emissions per capita, we will find that there are larger differences. So USA has the highest carbon emissions per capita, no matter for consumption-based emission or production-based emission. China and EU have very similar emissions per capita. India's emissions per capita are relatively smaller than these other countries. So we can say the emissions per capita in the USA and EU have been declining in the past 20 years. By comparisons, the emissions per capita in China and India have been increasing. So China has made the target to achieve the carbon peak before 2030 and achieve the net zero before the 2060. So it means that by 2030, the production-based emissions of China will be declined, and the per capita, the emissions per capita will also be declined. So here in this figure, we can think about an issue about decoupling. So if we want to achieve net zero, decoupling between GDP growth and carbon dioxide growth is very important. The decoupling between GDP and CO2, it means that the carbon dioxide emission will decline while the GDP is still increasing. So USA, EU have achieved the decoupling between the GDP and the CO2. China and India have not achieved the decoupling, but China is achieved the relative decoupling. It means that both carbon dioxide and the GDP have been increasing in China, but the growth rate of GDP is higher than the growth rate of CO2. So if we calculate the emission intensity, we use the carbon dioxide emissions divided by the GDP. So we will find that the carbon emission intensity in China has been declining. So this is the relative decoupling. So after 2030, so China achieves the carbon peak. So the country will achieve the absolute decoupling between CO2 and the GDP. So the transfers of emissions embodied in trade between OECD and non-OECD countries has been declining from 2000. As I introduced before, the trade between North and South accounts for a large proportion in international trade. But since 2000, the emissions embodied in trade between OECD and non-OECD countries has been declining. The gap has been declining. So this is caused by the pattern change in international trade. So we estimated the emissions embodied in trade between global south, between the developing countries. So we find that the emissions embodied in South-South trade has been increasing very fast in the past 2 decades. So the South-South trade, it means that the trade between developing countries. So in this figure, we can see that the emissions embodied in trade between global south has increased 3 times from 0.47 GT in 2004 to 1.5 GT in 2007. So these results are based on the GTAP database. So we can say the main proportions of emissions embodied in trade between global south are from China, India, and other emerging developing countries. So international trade might bring the carbon leakage. So we will introduce more later about carbon leakage. So the trade between the North and the South has been paid a lot of attention to talk about the carbon leakage between developed country and developing country. So in this figure, we can know that the trade between developing countries has been increasing very fast. So we need to pay more attention to the potential carbon leakage among developing countries. So we also grouped the countries into HDI groups, the Human Development Index. In 2020, so about 80% of global CO2 emissions were from the production of goods and services traded between different HDI groups. The very high HDI group is the only one group with higher consumption-based emissions compared to their production-based emissions. So for the very high HDI group, its consumption-based emissions per capita was highest. So it is 1.3 times than the global average and 26.3 times higher than the emissions per capita in the low HDI countries. So there are still very large gap between the developed countries and developing countries. So, we talk about the international trade and carbon emissions embodied in international trade. In fact, the emission transfers can also happen in one single country, within one single country, especially for some vast countries, such as in China. China is very vast and there are many provinces in China. So there are also emission flows embodied in the interregional trade in China. So this figure demonstrates the emission flow between 2007 and 2017. So we can see that the directions are from the west to the east. So you might know that for China, the western region are relatively less developed compared to the eastern region. So the flows of emission are from the west to the east. It means that the West China has been producing some high energy intensive by low end products, which are used by the production and consumption in the eastern region. So, but if we compare the net emission flows between the west and the east from 2007 and 2017, we find the gap between the west and the east has been declining. So, China has been implementing some policy to promote the development of in the Western China. So the gap between the West and the China has been declining. So the growth rate of consumption in many Western provinces is higher than that in Eastern China provinces. So when I talked to this before, so when we talk about the emissions embodied in trade, so it might cause the carbon leakage. So what is the carbon leakage? So carbon leakage occurs when there is an increase in greenhouse gas emissions in one country as a result of an emissions reduction by a second country with a strict climate policy. So there are merely three important channels for carbon leakage. The first one is through the energy markets. If a country has proposed a stricter climate policy, so the demands of fossil energy in the host country will decline. So it might make the fossil energy cheaper in international energy markets. So it might cost more fossil energy consumption in other countries. So this is from the energy market. The second channel is competition. So this is mainly the most important channel for the carbon leakage. Due to the causes of climate policy, industry relocates products and investment to countries with less climate, with the less strict climate policies. So it will result that the emissions in the host country decrease, but the emissions in other countries increase. So the third channel is from the technology, is the technology spillover. So this is a negative leakage because the technology in one country might lead to the innovation and technological development in another country. So this can aid the reductions outside the policy area. So this the energy markets and competitions will bring the positive carbon leakage, while the technology spillover will bring the negative carbon leakage. So we will focus more on the competition channel. So it caused the reallocation of production or the outsourcing. So outsourcing might cause carbon leakage because a reduction in carbon emissions in one country might be offset by an increase in emissions in another country due to the outsourcing of production. So let's assume there are two countries, country A and country B. Which country A needs 10 iPhone? The country A produced 10 iPhone, emitting 1,000 kg CO2. The country B produced 10 iPhone, only emitting 500 kg CO2. Maybe the country B is more developed with better technology and better energy structure, cleaner energy structure. So the global emissions between country A and country B is 1,500 kg CO2. So if country B wants to reduce carbon emissions and propose more strict climate policy, so due to the production cost increased by the stricter climate policy, the country B can only produce the 5 iPhone. But the country B still needs 10 iPhone because the demand is here. So the country A can respond to produce 5 more iPhone and export the 5 more iPhone to country B. So due to the climate policy, the country B's carbon dioxide will be reduced from 500 kg CO2 to 250 kg CO2. But unfortunately, the emissions in country A will be increased to 1,500 kg CO2. So now the total emissions will be 1,750 kg CO2. So this is higher than the original global emissions. So this is the carbon leakage. So this is why we want to talk about carbon leakage, because it will affect the effectiveness of climate policy in some countries. So when we talk about this carbon leakage, the technology transfer and climate finance will be a useful way to achieve the carbon leakage problem. So when country B outsources the production of the 5 iPhone to country A, if the country B can help the country A to reduce their carbon intensity, to improve their technology and provide the climate finance to make sure that country A has the same emission intensity as the country B. So global emissions will be reduced to 1,000 kg CO2. So technology transfer and climate finance will play a critical role in mitigating carbon leakage. So why climate leakage matters? So I talked one thing before. So it can undermine global emission reduction efforts. If emissions reductions are only achieved in certain countries or regions, but emissions continue to rise in other countries due to carbon leakage, then global emissions will not be reduced sufficiently. Many developed countries have achieved the decoupling between the production-based emissions and the GDP. So it means that their GDP has been growing, but their production-based carbon emission has been declining. But if we look at their consumption-based emissions, so for a long time, their consumption-based emissions do not decline largely. So it means that these countries can outsource their emissions to other countries with less strict climate policy. So this reallocation of the carbon emissions will undermine the global emission reduction efforts. The second issue is that the carbon leakage will cause the loss of economic competitiveness. So carbon leakage can result in a loss of economic competitiveness for countries that have stronger environmental regulations. If companies move their operations to countries with weaker regulations, it can put domestic industries at a disadvantage and lead to job losses. So this is also a very important issue caused by the carbon leakage. You know, many countries would like to make a contribution to mitigate climate change, but economic development is also very important. So due to the carbon leakage, due to the differences in environmental regulations, if companies are moved to other countries, the host country will lose their job. So it will cause the loss of economic competitiveness in the host countries. The second issue is that carbon leakage is the basic rationale for the carbon border adjustment mechanism, CBAM. So CBAM is to impose a carbon price on imports. So what is CBAM, and what will CBAM impacts the international trade and carbon emissions? So what is the CBAM? The carbon border adjustment mechanism is a carbon tariff on the carbon intensive products. So in practice, the EU importers will buy carbon certificates corresponding to the carbon price that would have been paid had this goods being produced under EU's carbon pricing rules, usually the EU ETS. So conversely, once a non-EU producer can show that they have already paid a price for the carbon used in the production of the imported goods in a third country, so the corresponding cost can be fully detected for the EU importers. So it means that when the EU have imports from other countries, if this import do not pay any carbon price, the importers need to buy the carbon certificates according to the carbon price in the EU ETS. But if the imported goods have been paid the carbon price in a third country, such as it has been paid in the UK, it has been paid in the USA, in China. So these countries might have the carbon tax or carbon emission trade market if the imported products has been paid a carbon price. So they do not need to buy the carbon certificates. So it can be reduced. So this is the CBAM. It's a carbon tariff on the imported products. So here is the timeline of the EU CBAM. You know, in fact, CBAM has been discussed for a very long time. So in 2021, the European Commission adopted its proposal for a CBAM. 1 year later, in 2022, in May, the European Parliament Committee on the Environment, Public Health and Food Safety voted on the CBAM. In June 2022, the European Parliament adopted its position on the regulation with 450 votes for and 115 against and 55 abstentions. So in December 2022, the European Parliament reached a provisional agreement with the Council of the EU to implement a CBAM from the 1st October 2023. So CBAM is coming. So it will start in October 2023. But at the first stage, the importers only need to report information of carbon, but do not need to buy any certificate. So there is a period, 3 years for this. So why CBAM? Why CBAM is necessary for the EU? So to answer this question, we need to know the EU's climate ambition. So EU is always a climate leader around the world and shows great ambitions in combating climate change. In 2020, the European Green Deal was approved, so with overreaching aim of making EU the first climate neutral containers in the world in 2050. So this is a very ambitious target. The European Green Deal will transform the EU into a modern, resource-efficient, and competitive economy, ensuring no net emissions of greenhouse gas emissions by 2050. So the European Commission has adopted a set of proposals to revise and update EU legislation to make the EU's climate, energy, transport, and taxation policies fit for reducing net greenhouse gas emissions by at least 55% by 2023, compared to the level in 1990. So this is called the Fit for 55. So it means that the EU has to reduce their greenhouse gas emissions by over a half by 2030 compared to the 1990 level. So this is also an ambitious target. So in the EU, the carbon pricing is merely EU ETS, the EU emissions trading system. So it is the world's first international emission trading scheme, and is the EU's flagship policy to combat climate change. EU ETS has a very large impacts all over the world in mitigating climate change. So it is the first international emission trading scheme, and many other countries, when they want to establish the emission trading system, many other countries are learning experience from the EU ETS. So it sets a cap on the amount of greenhouse gas emissions that can be released from the industrial installation in certain sectors, and allowance must be bought on the ETS trading market through a certain number of free allowance is distributed to prevent carbon leakage. So under the EU ETS, all companies have been allocated the emission allowance. So if the emission allowance are not enough for their production, they have to buy the certificate from the market. So in this way, it can achieve the most cost-effective ways for the economy. So the EU's carbon emissions has been declining from the 1980s. So we can see, especially after about 2010, it has been declining very fast. By comparison, the EU ETS carbon price has been increasing. Especially after the COVID, the carbon price is much higher. Now, the carbon price in EU ETS has achieved 100 euro per ton. So this is generally is a very higher carbon price compared to carbon price in other countries or in other regions. So the carbon price, especially the increasing carbon price, is causing the competitive loss of the EU's domestic products. So let's assume that this for a cost of a product or service, so in the EU, so it has the cost of a carbon price and other costs. Due to the increasing carbon prices, the carbon price may continue increasing due to the more ambitious climate policy. So the cost due to a carbon price will also be increased. So if we compare to the imports from the country without carbon prices or with a relatively lower carbon price, so it will cause more competitiveness loss for the domestic production in the EU. So the CBAM aims to equalize the carbon price of domestic and imported products. So if the imported goods or services are from the country without carbon prices, so the EU will have the tariff of the CBAM to level the playing field. So this is why the EU would like to propose a CBAM. So there are merely two reasons. The first is to avoid the carbon leakage. The second is to increase the economic competitiveness of the domestic producers in the EU. So how will CBAM work in practice? So according to the current policy, the CBAM will the CBAM will only focus on the scope 1 emissions. So whether to extend to its scope 2 emissions will be evaluated by the end of the transition period. So I will introduce later what is the scope 1 and what is the scope 2 emissions. So there are 5 sectors in the CBAM: cement, iron and steel, aluminum, electricity and fertilizers. So merely the raw material sectors. So these sectors have a high risk of carbon leakage and high carbon emissions. The administrative feasibility of the covering sectors in the CBAM from the starting was also taken into account. You know, some other sectors are also very important, might have carbon leakage, but it's very more complex to include these sectors. So at the beginning, only these 5 sectors will be included. So between 2003 to 2005, this is the transitional phase. The EU exporters report the emissions, but do not need to pay any certificate. From 2006, it will be operational. So the EU importers have to purchase certificates. Between 2006 and 2034, the EU ES will phase out the free allowances. So what is the scope 1, scope 2, and scope 3 emissions? So the scope 1 emissions are all direct emissions from the activities of an organization under their control. And scope 2 emissions are indirect emissions from the electricity, from the heating purchased and used by the organization. So, and scope 3 is all other indirect emissions from activities of organization occurring from resources they do not own or control. Generally speaking, scope 1 and scope 2 are mostly within an organization's control, and the businesses also have less control on how scope 3 emissions are addressed. So, for example, for a construction project, the emissions from burning of fuels on site will be the scope 1 emissions. Emissions from generating electricity, which is used by this project, is the scope 2 emissions. And the emissions from generating materials which are used by this project, such as cement, steel, glass, will be the scope 3 emissions. So now for the CBAM, so it will only cover the scope 1 emissions. So the scope 2 emissions were also discussed at the beginning, but in the final policy, so scope 2 is not included. So after the transformation period in 2025, so whether scope 2 or scope 3 emissions will be included will be discussed. So what we want to know is, will CBAM be effective to address carbon leakage? And how will the cost be shared globally? You know, according to what I said before, the CBAM seems very necessary for the EU to avoid the carbon leakage. But, you know, it has not started. We do not know whether it is effective to address carbon leakage. So we use GTAP model to do the simulations. So according to our results, first of all, so we need to know what factors might affect the effectiveness of CBAM. So both internal and external factors might have impacts, such as for the internal factors, the scope of emissions, the carbon price level, the carbon intensity measurement, the revenue usage measures will have impacts. For the external factors, it means the other countries' responses. So other countries might cooperate by implementing more ambitious climate policy in response to the CBAM. But other countries may also implement the trade retaliation. So other countries might treat the CBAM as a carbon levy trade barrier. So the use of counter tariffs by other countries might be inevitable and further cause uncertainty according to the impact of the CBAM. So according to our simulations, the best thing is that the effectiveness of the CBAM is limited. The global carbon emissions will be reduced by about 0.058% due to the CBAM, and the carbon emissions of developing countries increase by 0.016, while the carbon emissions of developing countries decline by 0.074%. So this figure demonstrates the changes of the carbon emissions and the GDP. So we find that for most developing countries, their GDP will be, their carbon emissions will be reduced. But at the same time, the GDP in developing countries has also been declined. So it means that developing countries might bear more economic losses due to the CBAM. So we also simulate if other countries implement trade retaliation, what will happen? Here, the trade retaliation assumes that EU's main trade partners will implement the trade retaliation and increase tariff of key products from the EU. So we find that the trade retaliation will weaken the CBAM's effectiveness. So without the trade retaliation, the CBAM can reduce the carbon leakage caused by the EU ETS by about 18.9%. But if there is trade retaliation, it can only increase by 16.5%. And if there is trade retaliation, the EU's welfare will be declined largely, and the poor countries will also have more welfare loss. So it means that if we have the trade retaliation, the EU and poor countries might suffer more welfare loss. So due to the carbon tariff, the CBAM, the export shrink in most countries. So we can see that, but the export of EU, EFTA, and the UK will increase, but for most other countries, their export will be declined. This is the BAU scenario. So without the trade retaliation, if there is the trade retaliation, the decline of the export will be much higher. So to conclude what I introduced before, first, international trade is critical for carbon emission reduction because the international trade can shift the climate burdens from importing country to exporting countries. This might cause carbon leakage. So carbon leakage will negatively affect the effectiveness of the climate policy in countries. So the EU would like to propose the CBAM to address the carbon leakage. But unfortunately, the effectiveness of the CBAM seems limited, and it might raise the concerns of exacerbating global inequality because the developing countries have more economic losses due to the CBAM. And in addition, the trade retaliation will lead to multiplied welfare losses, which would mostly be borne by poor countries. So climate change mitigation needs to be performed within the framework of international cooperation. Another issue is that the rising emissions embodied in South-South trade need to be paid more attention. When we talk about the emission embodied in trade, most attention has been paid to the trade between developed country and developing country is the north-south trade. But the south-south trade has been increasing very fast. So it means that there are high risks that the carbon leakage might happen among developing countries. So more attention need to be paid to the emissions embodied in south-south trade. Well, so this is my talk. Many thanks for your listening.